MATLAB stands for Matrix Laboratories. That means it is important to become familiar with working with matrices in order to fully use MATLAB. Here's an example of a simple 3x3 matrix. In a matrix, rows are always horizontal and columns are always vertical. So in the first row, we have the values 2, 6, and 8. And in the first column, we have the values 2, 3, and 7. To generate a simple matrix in MATLAB, we use the concatenation operator. For example, type in square bracket 1, 2, semicolon 3, 4, close bracket, and press enter. We've generated a simple matrix 1, 3, 2, 4. The square brackets are the concatenation operators in MATLAB. Whenever you want to generate a matrix, remember to enclose your numbers using the square brackets. The comma separates columns in MATLAB. We separate 1 and 2 with a comma because they're in separate columns. The semicolon separates rows in MATLAB, so we separate row 1, 2 from row 3, 4. If you would like to use space instead of a comma to denote columns, you can type 1 space 2 semicolon 3 space 4 and you'll generate exact same matrix. Another way to generate matrices in MATLAB is using the colon operator. For example, type in 1 colon 10 and we've generated a 1 by 10 matrix that counts from 1 all the way to 10. Notice we don't need the concatenation operator or the square brackets in this case because the colon operator always creates a vector for us. A vector is a matrix that has only one dimension, so it's only one row or one column. By default, the colon operator will always add 1 to your starting number, in this case 1, and will continue until it gets to your ending number, in this case 10. You can change the default step size by putting a number in between the colon. For example, we can put 1 colon 2 colon 10, press enter, and we'll get a much smaller array because we step 2 each time, skipping all the even numbers. You're also allowed to step a decimal amount of times, so you can step 1 colon 0.2 colon 10 and you'll get a much larger array because we're only stepping 0.2 each time. Using the same idea, we can step backwards. For example, if you type in 10 colon -1 colon 1, you'll step from 10 all the way to 1. Remember to place your starting number bigger than your ending number whenever you step negative, because if you step from 1 to 10 using negative steps, you'll always get an empty matrix because you can never step to 10 if you step in the wrong direction. The colon operator is also very useful for acquiring specific values in a matrix. Let's go back to the original matrix A. If we want to pull out the value 5, there's 2 ways you can pull out that value. One is to look at the row and column that 5 resides in. So 5 resides in row 2 and column 3. So if you type 2, 3, you'll be able to pull out the specific value 5. What we're telling MATLAB to look at is the first value always represents the row number, and the second value always represents the column number. And we've told MATLAB to look at the intersection of these two numbers, which happens to be the value 5. We can also pull out the value 5 by counting what position 5 resides in the matrix. MATLAB always stores these values in a specific order, and MATLAB counts the order down columns. So we would count position 1, position 2, position 3, position 4, and so forth, all the way to 5, which is in position 8. You can also pull out whole rows and whole columns in MATLAB. So for example, if you type A1, colon, you'll get the entire first row of the matrix. What we told MATLAB to look at is the first row, but instead of looking at the intersecting column, we're looking at every single number in that column. So here, the colon operator represents every single number in an array. Similarly, if we type in colon 1, we'll get the entire first column of the array. You can also pull out specific sections of the matrix, such as a 2x2 matrix 2, 3, 6, 2. To do that, type in 1, 2, 1, 2. Press enter. We've told MATLAB to look at the intersection of rows 1 and 2 and columns 1 and 2, which happens to be a 2x2 array. Finally, there are some useful functions in MATLAB that can help you generate simple arrays quickly. A useful one is the I function, which generates the identity matrix. You simply type I and place a number, and it will generate a square matrix, in this case a 5x5 matrix. You can change the identity matrix to a rectangular matrix if you choose to do so, but remember, only square matrix identity matrices can be used in matrix calculations. Another useful function is the ones function, which generates a matrix filled with all ones. And similar to the eyes function, you can create any sized matrix by telling the row and the column number to the function. Zeros is very similar to the ones function in that it fills the entire matrix with zeros instead of ones. And finally, we have the rand function, which generates an array of numbers from 0 to 1. So if we put 5, we generate a 5x5 array where all the values are from 0 to 1.